Welcome to the Heretical Algorithms channel. No AI script or voicing will ever be used on this channel, unless it's some clip of someone else's video which I'm reacting to, or something like that. I might put some generated art up there just so that there's something to look at, but no AI voice, no AI text, and especially no AI code will ever be used on this channel. C versus C++ has been a raging debate practically since the dawn of time. I actually started learning C++ as soon as it did come out, but I've programmed in C as well, among many other languages over the years. I watched a video by a guy named Eskil Steenberg, where he explained why he believes C is better than other languages, which makes sense because he's a C programmer. For once, somebody actually had something coherent to say on the subject. I disagreed with many of the points and the ultimate conclusion, but he does set a good stage for the discussion, so I'm going to address some of his points. I'll probably also show clips from a few other people as places to start riffing from, like probably Tim Kaine too. But let's start with Mr. Steenberg first. He wears a man bun in his newer videos, so he must know what he's doing, right?
C++ tried to be clever, and cleverness is like the root of all evil. It's not premature optimization. And the worst thing about C++, in my opinion, is that C++ allows you to do some clever stuff that makes you think you're clever when you're really dumb. And people are sort of proud when they use features like, operator overloading and things like that, when they're just really doing stupid stuff. And another thing about C++ is that it tries to hide things, and I think that's the root of a lot of evil. You don't want to hide things, you want things to be very explicit. So let's check out some examples. Operator overloading is just horrible. And usually what people say is like, well, it's bad, you can do bad things with it, but it's really good for some things, like vector math, right? You can build a vector type that just and then you can write, vectors, and it's awesome. And then I usually show them this line where you have, two vectors and a multiplication between them, and then I ask them, what is this? Is this a dot product or is it a pairwise multiplication? And usually if I'm with a group of people, everybody says, well, that's easy, and then half the room says pairwise multiplication and half the room says dot product. So basically everybody thinks it's clear, but it's not. And therefore, read the code below. This can't, be misunderstood. This is like ultra clear. This is a function that takes these things and it does multiplication and dot, and it's, you can't mix these two up. And that to me is like much, much, much better. So this cleverness is just like, it makes people think they're smart when they're really doing something dumb.
This criticism always makes me laugh. I mean, operator overloading, the horror, right? First off, while you basically never see operator overloading in the kind of case he's talking about, even if you did, so what? If you're using a library like that, you're going to use it over and over again, and you're just going to look it up the first time and figure out what they're doing, and then remember that and do it over and over again. You don't just use a 3D math utility library one time. People may not realize it either, but there's a lot of very big assumptions built into vector math libraries, such as the ever popular GLM. It could be done much differently, but people are just used to having it in a certain way. So for this specific example, it really does fail to illustrate the problem, because there really isn't a problem. Now, some people might argue it's better not to have it anyway. After all, the simpler you keep things, the better, right? Is that true, though? What is it there for, and what's the consequence of taking it out? In short, without operator overloading, template metaprogramming doesn't work, and object-oriented programming is a lot more difficult. For example, I have a multi-threaded quicksort implementation implemented as a template. This allows me to sort all kinds of things very quickly, even if it's not a simple type like float or int or whatever. The big O notation is still in log in, which quicksort is always going to be, but the expected runtime is actually linear, and you only get in log in runs with the worst case data. I used to have open source Maya plugin online that people could download, and the people that did use it were really happy with it. And this template was the key to sorting the vertexes very quickly and allowing you to do operations on meshes like smoothing and sculpting, auto skinning, conforming one mesh to another, and on and on. That is, you could take a lower res mesh and wrap it to the original higher res mesh with millions of vertices, and you could make sure that you get something that fits really well. What happened to it, I have no idea, but it's no longer on SourceForge today. But I'll try and put a few code snippets up there for you to see. Without operator overloading, you couldn't use less than, equals to, or greater than signs with many data types. And you'd have to create an extra data set of keys just for comparison. In short, template metaprogramming would be very cumbersome to the point of uselessness. Trying to do all that in C would be pretty much impossible, or at any rate would have taken about 10 times as long, and it took a long time to really perfect that sort because it's extremely high performance. In fact, I did the sorting for reasons that were totally unrelated to the plugin project. So without that kind of generic functionality of templates, this plugin project would never have existed. And it basically turned slow and clunky Maya into something you could use to sculpt models with millions of verts with good performance, because in Maya you're able to make C++ plugins. No operator overloading also means that IO streams aren't really going to work, so you'd have to use tools like printline for everything related to output. Some people will say great, but you have to format things just so every single time you do a print line, and I find this to be irritating and really very slow as compared to just doing a plus sign and then whatever it is you have. So how much quicker could it be than that? You also have to deal with the issue of char star pointers in C if you're doing it that way, and that's one of the biggest sources of bugs in C. In general, using pointers is not a big deal, especially in object-oriented programming, because almost all of that is going to happen automatically in the constructors and destructors anyway. C-style char star use for text is another story though. You get good at it the more you do it, but you're bound to make a few mistakes here and there, and over time you're going to introduce security issues, especially when you have a lot of programmers working on something, and some of them are going to be a lot less capable than others. And these can be very hard to detect and may only happen in very rare circumstances. And if it's an open source project, it may be something someone is doing intentionally to make a backdoor. And that's probably why these are the most common source of code injection attacks. You might say template metaprogramming is bad too, but the alternative is macros. Macros come from assembly coding days and carry over into C and C++. They allow arbitrary bits of code to appear wherever you put some label, and often you're going to use this like a pseudo function, taking some inputs and doing who knows what with it, and it totally skips the compiler to do this. So basically it's like you have a function with hidden implementation details and no type checking. You also can't easily check the source code for it either, and sometimes it doesn't generate exactly what you think it's going to. So you can basically completely break all the rules with macros and cause all kinds of problems that are very difficult to fix. At the start of the clip he talks about the compiler giving more errors being better, but it's clear that C fails here compared to C++. In fact, Linus Torvalds had a pretty good rant about macros a while back, and rightfully so. A macro is a giant security hole for open source code because anyone can redefine it at any time, at any place, to do something malicious, So it's especially bad for the open source community, and you can just have this one harmless looking macro that actually corrupts your whole system and takes it over. And you can't just ignore it either. If you want generic data structures and algorithms in C or C++, then you're going to have macros. Either that or templates plus operator overloading. Some C programmers use other people's libraries and may not be using it directly, but they're definitely making use of it indirectly if they're making a significant standalone application. And usually any big one I've worked on is just full of macros because it greatly reduces code duplication. I'd also like to bring up type defs here and see you can redefine your own type, which is really something much more complicated, into a simpler looking type. This looks prettier but causes a ton of problems for encapsulation. It makes things convenient for the original programmer and makes for a simple looking interface, but it's a nightmare to maintain over time, both for the people using the code and as a third-party library. Macros and type defs do exist in C++, but no one actually uses them except where forced to. Maybe when they're learning, someone might randomly overload operators, just like they might randomly use some weird macros or type defs, but it's actually a lot of work to do that, so it's just not really an issue. And no one is going to use macros when templates are available, because again, it's quite a bit of work, and so at least in this regard, C++ is both easier and cleaner than C.
I think I have some other thing. Yeah, so you have, overloading here. And that again is, one of those practicalities that people think are awesome. So here I have 3 implementation of add. They're obviously what they do. I have for integer, I have for float, and I have for doubles. But then the thing is, what happens if I just type this? Well, this is for this is integer, and this is a double. So which one of these does it pick, right? That's really not clear. And if you look at the C++ standard, it actually, defines which one it is. The problem is most people aren't going to know that, and even if you do know that, it's not super obvious which one it is, and therefore it might run the wrong one. You might think this run the float one when it's really run the integer one, and if this is say 0.3, this is actually not doing anything now because it's adding 0 to 4, and you might have a bug here just because of clarity. So therefore, why is it not better to just put an F here, right? And now it is a float version of this, and you can immediately see that. You get a warning if you're doing something wrong, and the compiler will be a little bit more annoying maybe, but it's so much more clear. You won't accidentally do anything, and it's typing one more characters for a little bit of clarity, and not spending an hour or maybe, if you're unlucky, days looking for that bug. That is a really good thing. You're saving a lot of time.
This is more preference than anything else, and the evaluation the compiler does is very thorough, so it's not really a problem. If you send 4.4 to an integer function, it's going to complain, and also to a float function. 4.4 is evaluated as a double, 4.4f as a float, and 4 as an integer. It's also returning the result as a type, so it's not really something you can screw up. The compiler is going to complain every time. I'd also say don't expect the compiler to catch actual bugs or ever think a code section is bug-free. That's a very bad assumption. You only know what your code has done, not what it might do. Until an error happens and your bug is ultimately exposed, that is. To handle bugs, you really need testing, and that is seldom even thought about by many programmers as they go. And every time you add in more code, you invalidate the previous testing. So it's not like you just have these sections of code that are just totally solid, which is what most people seem to believe. Bugs in C++ tend to be actual mistakes. Say you assign a value to x.z instead of x.y. Sometimes this causes an obvious bug, but sometimes it's not exposed immediately, and you get an error much later in time. For example, if you've programmed in Perl, you know it has very loose typing. This can lead to a few specific errors, but you quickly learn to watch out for them. I've never sat up and thought, gosh, I wish Perl had some way to find my errors before I run the script, because that's mainly a fantasy. You might assume that your compiler is saving you from endless bugs, but in reality, you always have to be the one who's on guard for mistakes, because the serious mistakes are not going to be found this way. And just because it compiles doesn't mean you don't have all kinds of bugs in there. On the other hand, Perl's basic lack of organization and inability to compile down to a standalone executable make it pretty much useless for making a standalone application. It's really just good for logs, web crawling, email, running backups, and other sysadmin style jobs that just about every programmer is likely to do at some point in their life. And keep in mind, it's a lot easier to learn languages like C and C++ than you might think. And if you don't understand the low-level stuff that's going on, it's always going to be hard to really use the higher level stuff too. It would be nice to catch our actual errors even before running, but this is more difficult than many would have you believe. Personally, I'd settle for compilers that don't cause extra bugs or debugging issues, but that's another story, and one where C++ could definitely use some improvement.
I also think that actually long functions are good, and this is another controversial thing because there's actually like computer science people that teach that you should never have a function with more than 5 lines of code, which to me is just moronic. Sequential code is really easy to read, right? That's how we read books, read from the top to the bottom. Reading a choose your own adventure book where you have to flip to page 57 to finish a sentence, that's actually much harder and not as easy to read. And the other thing is I like writing code that does something, and a lot of people, if you have a lot of functions for things, people tend to write a lot of functions or things that handle other code. So if you see that you have a lot of your code be called things like something something manager, or your something something controller, or something something handler, you're probably not writing code that does something. You're writing code that handles other pieces of code. And I think that's like a warning flag, because it's really hard for someone coming from the outside, like, knowing what that handler actually does. Where if it's a function that is like clearly assigned as this function does this thing, then it's much clearer what's going on.
This really comes down to whether you're doing things in an object-oriented programming way or not. I'll try to come up with an example that's not too brain-dead on the fly. Say we have a metadata string on disk, and that defines both an object data that can be stored and loaded to a database, and an editing tool that creates a user interface based on it. So we may have a function called bool create interface from loadable object parentheses loadable object star space loadable object, and then loadable object.load metadata, loadable object.load from database, and so on. In a few lines you're doing a whole bunch of stuff, including creating an interface to edit an object. Creating the pop-up might be hundreds of lines of code and use RTTI, for example. It's also reusable code that could be called from many parts of the application, and you're probably going to be creating this pop-up from many different places for different purposes. In C, you have limitations on reusability unless you get into some very complicated and difficult to debug macro use, or you generate out your C code objects based on metadata, or you have function pointers and stuff like that. Things like loading the object definition from a file, loading the value of a particular object from the database based on a key, saving the database, creating a data entry screen. Each of these is a lot of code, and it can be used in multiple places. We'd like to have something where we just write this one time for all of these different database objects. That way you get rid of the laborious process of writing individual load and save SQL strings and testing them. You can do all the SQL query generation and testing automatically, and all of the creation of editor GUI automatically too. In big projects, there's going to be hundreds or even thousands of these objects, each corresponding to one or more database tables. So that's not to say that object-oriented programming does well for every case, What it does well for is when you have a lot of opportunity to make abstract logic that applies to many variations of something similar. Data objects that load and store to a database are obvious examples. GUI is another place that has a lot of obvious benefits. In the clip, he mentions things like handlers and calling other functions and function pointers and so on. And that's not something anybody wants. It's just something that's forced on you by the functional requirements and by the C language. But in C++, you don't need a bunch of convoluted handlers and type defs and function pointers, except sometimes the interface with C-style libraries, such as OpenGL, for example. Instead, you would probably use a listener, which is a lot simpler. You would have a class called, say, button listener with a method pure virtual void button action parentheses equals 0. That means that any class that inherits from the button listener class has to implement this method and be a concrete class that you can actually instantiate. Somewhere there's a data structure holding all these listeners, and they get activated when appropriate, whenever the button is in focus or clicked on or whatever. They can also be added and removed from the data structure as required, or you can change the button to have totally different listeners or multiple listeners. In essence, you have a function pointer, but without all the opacity and confusion and potential error. It's clear where they're all defined and what they do, and they can be much more easily changed out as needed to make a context-sensitive GUI interface. By contrast, in C, the more complexity of this sort that you have, the more things tend to go off the rails. C is basically good for a hardware driver, command line utility, or for calculation, but it's not very good for moving a lot of data around or making a complex GUI. So for general application development, C++ will be a much better choice in this respect, but for a file system, driver, or sound library, it should do great. On the other hand, the module in a C program is very well defined, while that is not really the case in C++. The machine instructions also closely mirror what you actually type for the C code in most compilers, and in C++ it can be really mystifying to see what they generated. This can cause some debugging problems with C++, and it makes things less secure for some uses, like open source software, for example. So if I wanted to write something like the SSH utility, I would definitely use C, but if I wanted to write something like a game or a content creation or editing tool, then I would definitely use C++. That's not to say you can't do literally anything in C or C++. In fact, aside from assembly, these two are the only languages I would make that proclamation for. There are many catches to some of these newer languages that make it unsuitable or downright impossible for certain applications, or really for anything that's just a totally standalone deployed application. And being smart and experienced, along with the knowledge of computer science, is always going to be the thing that matters the most for your results. However, without the plus part of C++, you're going to lose some extremely important tools that make life a lot easier for most projects.
So let's talk about object orientation. Object orientation is something that people think you cannot do in C because it's not an object-oriented language. But I find that object orientation is very straightforward in C. And in fact, I think it's better in C than other languages, because other languages tries to fool you into thinking there is such a thing as object orientation in computers, where it really isn't. It tries to tell you that there's, something that has both code and data in it, and that's actually not true at all. Code and data are separate. In fact, on modern CPUs and modern operating systems, it's required to be separate, because data is stored in a read-write able memory, whereas code is in execute only, and you can't read it and you can't write it. And that's to stop a lot of malicious attacks, so that you can't trash your memory and then have the CPU read that as code and do bad things. So therefore, you basically write protect all the memory that can run. So memory can either be run or it can be changed. And that's sort of a security things that, yeah, exist everywhere. So objects are just fundamentally wrong. So if you have a programming language that object oriented, you might recognize this, right? You have a thing, you create an object, and then you do something with that. Well, actually in C, you can make something just as simple. You do an object create, which is a function that returns a handle. And then you can just have a function that takes that handle, and then maybe, if you want to do something more, you can, add any parameters you want after that. This to me is actually clear. It says that it's a function, it's a piece of code that does something on a piece of data. And this is also a little bit nice for other reasons. Like, for instance, you may have a function that takes more than one object to do something with it, like transfer data or something like that. And then it sort of just proves that one object is not, worth more than the other. It's not one object calling the other object. It's a function using two objects. So to me, that's much more clear. And void pointers are really your friend here. I think there's a slide showing you how. Oh, no, it's not. So I'll actually show you. So I'm going to show you an example of a library that I have called Testify. So Testify is a library that does storage of binary data, and you can set up a handle and then send data to it. So let's take a look at how I've implemented this API, and you'll get an idea for why void pointers are really neat. So here's a function called Testify Network Stream. Obviously that's, it lives in Testify, and it's a networking thing, and it's stream, whereas over here we have datagram, which is for UDP, and this is for TCP. And then we have address create. So this is a long ass name, and you give it some parameters, and it outputs a handle. And if we look at that handle somewhere, oh, it's an internal. That's actually a void pointer. And that means that it's not defined here. All we say is that this thing basically gives you a handle, and here it, here it requires a handle. So for instance, if you want to tell the stream send everything, you want to force it to send, you just give it, the handle, and then you go. The application itself that is using this API has no idea what this is. It's just a pointer to something. It's a void pointer. You can't read to it, you can't write to it, you can't do anything with it except give it to all the functions here, right? So we've created something like that is opaque. Now, if we go into the actual implementation of this, we'll find that there's a t_internal that looks like this, that actually has a bunch of stuff in it. So here's all the buffers and everything, and this is t_handle. So this is the definition of a handle, but this is not shared with the outside world. This is what the actual functions are using internally. And if the user were to change any of these values, they may fuck something up, they may, crash the computer, do bad things. So we don't want the user to do that. We don't want them to have direct access to any of these memories. We just want to give them a pointer. And therefore, we define all our external functions to have this void pointer.
Well, it's not, though. This is not just a void pointer, it's full of implementation details. It doesn't matter if the interface to the person using the library stays the same. I mean, in any sane API, that's going to be the case unless totally new functionality has been added. I don't remember what he said this was for, but since it appears to be networking related, I'll use something I created in grad school in the early 2000s as an example. In a class on cryptography, I made a whole cryptography library implementing all the big algorithms of the day. DES, triple DES, AES, RSA, Blowfish, and a couple others I can't think of off the top of my head. I don't remember how I did it at the time since it was decades ago, but with C++ you could do something like this. You have a class called reader, and you'd have a class encryption algorithm, and you would do all the encryption stuff within that class. This way the user has a very simple and easy to understand API that's completely encapsulated. Not only does the user code not have to change, but we don't have to worry about changing the type def all the time. If we add a new encryption algorithm, you don't have to go back and rewrite these old algorithms or wade through the implementation details in some super long function. And that's what's usually going to wind up happening in C. This is how you get stuff like the infamous issue of very long case statements that are rickety and impossible to get rid of because they're embedded into a giant mass of code. Like that pirate software guy everyone was making fun of for a while. You know, the guy who worked at Blizzard for 7 years? Well, he was using RPG Maker, I think, but the same exact thing happens in C all the time. And once you get into that situation, it's almost impossible to get out of it. Just keep in mind, object-oriented programming is not about data, and that is one of the main ways that people fall on their face when they're trying to use it. Data is also easy to work with and to generate documentation for, so many tools will focus on data, and this leads to obfuscating what is actually happening with false layers of abstraction. You're not really trying to abstract the data, you're trying to abstract the functionality. Object-oriented programming is all about functionality and splitting out functionality when it's not related and creating generic functionality for the things that are related. So you could add in endless new algorithms into this paradigm and never have to mess with any of the old algorithms at all, ever. And at the same time, if one algorithm is highly related, you could just inherit from that one as your base and work on top of that. So a goofy example would be class terrible encryption, public encryption algorithm, public virtual void, transform 64-bit const char star, transform me. And then you have, inheriting from that, less terrible encryption, public terrible encryption, public virtual transform 64-bit const char star, transform me. And then it calls the method of the other algorithm that it inherits from. And then it does rot13, and then it does Zor with pi. And you could do any sort of silly things like that you want. And while those sound silly, they do add a little bit, not so much of security, but at least randomness, which can be helpful for a lot of applications because most people don't realize this, but an encryption algorithm and a random number generator are actually the same thing. So you get the best of everything programming this way. There's a place for everything and everything in its place, and everything isn't all jumbled together, and you can just add stuff on without interfering with other stuff that's already there. It's clear for the user and it's easy for the library maker to maintain, and even if someone doesn't have any idea what's going on, they can come and add their own encryption algorithm with no problems. Object-oriented programming lets you concentrate on how you use things and allows you to do it in a way where you should not have to constantly refactor, no matter how many little changes in functionality happen in the future. And that's the whole point. You never should have to totally rewrite stuff if you got the basic class structure right in the first place. With C, you can have something akin to this, but only in a more convoluted way where you'd have to sort of have a master data object that accounts for all the possibilities. And if you add in a new form of algorithm, that's probably going to have to be changed. And then you have some function pointers for the various functions that actually implement the algorithms. And you're going to have to update that every time you change something. And you have some switch somewhere which figures out what to call for which object and so on. In short, it's really no better than simply having totally separate functions for separate use cases. And in general, trying to do things this way only confuses things even more. So save object-oriented programming for your languages that support it, and otherwise, don't use it. One thing that people often discuss is performance in C versus C++. I'm going to show a clip from Tim Kaine to talk about that for a moment.
So I had a really good grounding in how to use C for games. However, the engine, the source engine, which we used for Bloodlines, which came from Valve, was in C++. So we switched. Now, a lot of people ask, why didn't you switch earlier? I was asked that question a lot. In fact, I was asked that question in a very rude and direct way when we were shopping around Arcanum. Somebody basically said that I was an idiot A potential publisher said that I was an idiot for not using C++. And my response was, I compared C++ and C. Usually the same compiler could do both. And I compared their output. I found optimization throughout the 90s worked way better on C code than C++, and the resulting executables were smaller. And that combination just led me to mainly work with C. You had to watch your memory and speed back then. Now, by the time Bloodlines came along, we didn't have a choice, and we used C++, and I was pleasantly surprised that optimization had gotten better. It wasn't perfect. Even in the 2000s, you would frequently compile your code with some optimization flags, and it wouldn't work. But then you turn off the optimization flags, and it would work, meaning there was a bug in optimization. Then you look at the assembly, find out that it had unrolled a loop incorrectly or put in an incorrect jump, and you'd fix it. By the way, it shocked me to my core in the 2010s that there were professional programmers using C++ compilers that did not know you could do that. That what they would do is if something wasn't working, they would switch off all the optimization, and if it worked, they would either switch them on back on one at a time until it broke and then not use that optimization, or they'd use pragmas to turn off optimization in certain parts of the code, but they never actually figured out why it was broken.
So are you a fool to choose C over C++? At the time, not as much as today. Today, this is true when talking about full-featured applications. Like if you wanted to make the next 3D Studio Max or Maya or a game or Photoshop or just an alarm clock on Windows. The one thing that's little understood though or ever mentioned is memory size in C versus C++. The size of a C++ executable is often gigantic. This has no effect in small programs, but it is one of the main problems in modern computing as far as performance goes, especially when you have 20 different programs running, especially if it's a bloated piece of garbage like Firefox. It's a more or less invisible tax that most people are never going to see. Most people just measure performance stepping through in a debugger and tallying the time taken in each subroutine. But this is not going to tell you about the big picture performance issues that you're having. It also won't debug issues related to poor use of algorithms or architectural issues. So this kind of so-called optimization has very little utility in practice, especially since modern CPUs rely heavily on branch prediction. So you're probably taking things out that were never going to be looked at anyway. Memory footprint is an area where C always wins out over C++, but if you're aware of the problem, you can minimize it by limiting how your header files allow the bloat to spread. I'm not going to go into all the details of that in this video because it's a giant topic unto itself, but it's something to keep in mind, especially as your programs get very large. Are the C compilers generating actually faster code though? This may seem to be true, but again, as programs scale, this is not going to be very noticeable. It may be pretty noticeable in a hello world type program, but not in a real life program. In theory, a C++ compiler today is going to be as good as or even better at optimizing. On the other hand, in C, it's easier to minimize memory footprint. And back in the day, memory was incredibly tight, and it still can be on many platforms that you might want to use. If you have only a megabyte or so, then you can be sure you're not going to use a long or an unsigned short will do. Today you might actually make your performance worse that way because memory alignment can be very important to performance. Keep in mind though that computer science is always your main method of optimization, and in spite of what many say, this form of optimization should be in your mind from day one. After all, algorithms and data structures are the very keys of programming, not just computer science. If you succeed on this front, your performance will be good throughout the project, and if not, merely shaving instructions from a loop here and there isn't going to do anything to fix it. And that's where C falls apart in the modern age, at least when it comes to making feature-rich applications. If you have some little bit of code that runs in the kernel and you want its memory use to be as tight as possible, then a custom single linked list written in C is fine. If you are making ZBrush or Fallout 2, then making a one-off data structure in C is going to be far from ideal. You're going to have to make much more robust and fully functional data structures, and doing that in C is a huge time sink. And since there are no templates in C, this is going to be an unpleasant task, and making something in C that's generic, has good performance, and is easy to maintain is quite a lot of work. And there are libraries for this, but they're not going to work as well as you think they are, and they're not necessarily going to be bug-free either. And even when you're using C++ and have the STL and other libraries available, there's a lot to be said for doing it yourself, especially when performance is an issue or where you worry about the stability of the code. If you have something running on multiple platforms, for example, you may want to have as few links to outside libraries as possible. If you're making a game or content tool, then you may have special performance or functionality needs too. So to make your life easy, you really do need templates to make these large, robust applications in a timely manner. Otherwise, you're going to get surprised by how disappointing readily available data structures are, and also how bad a quickly cobbled together one is going to be too. Another area C is not the greatest is threading. While pthreads work great, they're not really available on many platforms such as Windows, not with a full implementation anyway. That doesn't matter for many programs, but again, for a full feature program that has high performance and responsiveness needs, this is critical. C++ has cross-platform threading libraries available, and the newer versions have it built right into the standard. In modern computing, if you don't have easy access to fully functional threading, you're way behind the curve, and you're not really going to make a real application that way for the most part. Not all is better in C++ though. It has some weird gotchas. Most of them will never affect most people, but sometimes issues like static dynamic initialization order can cause big problems because it's not well defined, especially when people don't even know its existence in C++. But if you know about it, you can look it up and find ways to forestall this issue. If you don't even know though, some of these more esoteric issues are going to be very difficult to fix, to put it lightly. The thing is, these are all issues in computing itself, so just as you can't get away with not knowing how things work at a low level in the long run, the same applies here. That is, you really need to know what's going on in the computer, how the initialization works, and so on, or you're never going to fully maximize your abilities and be able to really know what's going on. Improper use of inheritance in C++ can also cause people issues. You can even have objects inheriting the same class twice if you're not careful, or even multiple times. That is why pure virtual classes are preferable as base classes. That stops the possibility of a lot of undefined behavior. Once you're forewarned about this, it shouldn't really become an issue in practice. Just keep it in mind. A serious issue that's mainly sociological today is that many over apply so-called design patterns and create abstraction layers over every bit of functionality imaginable. This can lead to a lot of unneeded complexity, but again, preferring pure virtual base classes and realizing that object-oriented programming is about functionality organization and not data organization can cut out a lot of this crazy confusion. And it should be the functionality you want to use, not the functionality of whatever library. Don't rebuild the library. Build what you want to use and then map that to the library that you have, such as OpenGL or whatever. So what's the final verdict?
A quick reminder that what you are watching is real. This is not a reenactment, and when Judge Wapner renders his verdict in just a moment or so, it will be legal, binding, and final.
The advantages of C: better defined module, smaller memory footprint, compiled machine instructions closely match the C code, easier debugging, slight performance benefits, simple, well-defined initialization process, While object-oriented programming offers a lot of power, sometimes it can greatly confuse people too, so C is better in that regard. It's a little simpler language. So what are the C++ advantages? Template programming is both more powerful and safer than the alternatives in C, allowing for custom, very flexible data structure and algorithms. Cleaner alternatives for messy features like typedef, function pointers, handlers, and inscrutable indirection. Object-oriented functionality that's separated where needed and done generically where it's not, so you get the best of both worlds. Easy string and output manipulation that's easy to extend and pretty much error-free. Pointers still exist, but most issues are resolved by use of constructors and destructors. Runtime type identification in C++ allows you to look at metadata describing C++ classes, and that makes even more generic programming solutions possible. Cross-platform multi-threading is easily available. Strongly typed but flexible about where and how things are declared, so it really just works pretty well in that respect. At the end of the day, C++ is a better language for almost every purpose, and the more complex and data intensive the application, the more you're going to benefit from the extra feature set. However, C should be preferred in areas where security, transparency, small memory size, and maximum portability are required. So if you make a utility in C, you should be able to run that essentially everywhere. So that's it for now. I hope you enjoyed it. I'm not sure when I'm going to make another video, but if people have any interest at all, then I'll probably try to eventually go to where I'm making something once a week. That is, if I still have the interest myself to talk about this stuff.